In this video here, we're going to take a look at geometrical problems. So we can use the properties of complex n-fruits that we established in the previous video to solve geometrical problems. So just note then that the n-fruits of any complex number A lie at the vertices of a regular n-gon, with its center at the origin. And we can find the vertices of a regular polygon by finding a single vertex and then rotating that point around the origin. And this is equivalent to just multiplying by the n-fruits of unity. Now, if z1 is one root of this equation here, so z to the n equals s, and 1, omega, omega squared, so on and so on, up to omega to the n minus 1, are the n-fruits of unity, then the roots of this equation here, so z to the n equals s, are given as follows. So we have z1, z1 omega, z1 omega squared, so on and so on, up to z1 omega to the n minus 1. So in terms of an introduction here then to solving geometrical problems, we don't need too much more. Really, this video here is just a direct continuation then from the previous video. So to finish with here then, let's just work through one practice question together. So let's just have a go then at this one practice question here for solving geometrical problems. So for this question then, we're given an equilateral triangle which has its center at the origin and one vertex at minus 1 root 3. So for the first part of this question, then part A, we want to find the coordinates of the other two vertices. So for part A then, the first thing to note here is we do already know one vertex of the triangle, right? Minus 1 root 3. So we take z1 is equal to minus 1 plus root 3 I. Okay? And we can now easily obtain the remaining vertices here by taking z1 and multiplying this by the n-fruits of unity. Okay? So don't forget then that omega, our n-fruit of unity here, is equal to e to the power then of 2 pi over n. So 2 pi over n I. Okay? And in our case here, n will be equal to 3. So we obtain e to the power of 2 pi over 3 I. And we can express this now in mod arg form. So this is equal to cos of 2 pi over 3 plus I sine of 2 pi over 3. And this is just equal to minus a half. So minus a half plus root 3 over 2. So root 3 over 2 I there. Okay. So as we already mentioned, right, for the vertices here, let's just make a note. So the vertices are given as, so we have z1, which we already know, right? We were given that at the beginning of the question. We then have z1 times by omega. So z1 omega, that gives us the next vertex here. And then for the final vertex here of this triangle, we have z1 omega squared. Okay? If you went on to find z1 omega cubed, that would just be equivalent to z1 here. Okay? So just so you're aware there. But in that case then, z1 omega here, so z1 omega, this is equal to z1, so that's minus 1 plus root 3, times by omega, which is minus a half plus root 3 over 2i. So let's just put that all together then. So minus 1 plus root 3i, like so. And then we times this here by omega, which is minus a half. So minus a half plus root 3 over 2i there. Okay. Now at this point here, you can do this by hand, and that's absolutely fine. But what I would personally recommend here then is just using a calculator. So the way to do this then, to begin with, is enter z1 into your calculator. So I do minus 1 plus I root 3, like so. I press enter then, and what this does here is it stores this complex number into the memory of my calculator. So what I do now is I do answer. So that takes this complex number here, and I multiply this then by this complex number here. So minus 0.5 plus I do the next bit in a bracket just to ensure I don't make a mistake here. So bracket root 3 over 2, I there, close that bracket and press enter. What this gives you now is Z1 omega, and hopefully what you obtain here then is minus 1 minus root 3i. Okay. What this has given us here then is the next vertex of our triangle, right? So in that case then, for the final vertex here, this is Z1 omega squared. So this is just equal to minus 1 plus root 3i. So that's Z1. We times this by omega squared. So that's minus a half plus root 3 over 2. I there. And then we square this bracket here, right? This is omega squared, like so. But the good news here then is by using your calculator, all we need to do here is just press enter again. What you should hopefully obtain here then is just 2. So the imaginary part here then for this next coordinate is just 0. So in that case then, what we've now obtained is the coordinates of the vertices here, right? So let's just summarize this here. So therefore the coordinates. So the coordinates of the triangle are given as. So what do we obtain here then? So we had the original vertex, that's minus 1 root 3. So minus 1 root 3 there. We also had minus 1 minus root 3. So minus 1 minus root 3. And then finally here we had 2, 0. So 2, 0 there, like so. And there we have it. So that gives us the coordinates here for the vertices of our equilateral triangle, giving us a solution to part A. So now for part B then, it wants us to find the area of the equilateral triangle. So just a quick follow on then from part A. So let me just draw a quick sketch here just to help illustrate this problem. Doesn't have to be perfect, by the way, just so we can see what we're working with here. As you can see, my axes are certainly not perfect, but what I've got here then is the real axis, and we also have the imaginary axis here, okay? And let me just plot the points here in a different color. Let's just do it in red. So we have 2, 0. That would be, say, here. That's 2, 0. Like so. We also have minus 1 root 3. So minus 1 root 3. Let's say that that is, say, there, for example. That's minus 1 root 3. And then finally here, we also have minus 1 minus root 3. So minus 1 minus root 3. Let's say that it's there, for example. Okay, so minus 1 minus root 3. So if we join these 3 points together, then we obtain our equilateral triangle. So as I've said, right, this isn't perfect, but it doesn't look too bad. So this here then is my equilateral triangle. So for the area of this triangle here, so area of the triangle will be equal to, so it's going to be base times by height divided by 2, right? Nice and straightforward here. So base times by height. And this is all over 2. So what would the base be here? Well, this is my base, right, for this equilateral triangle. So the base then would be root 3 minus root 3. So my base then is 2 root 3. We then times this by the height here. So what is my height in this example here, this equilateral triangle? Well, my height then would be 3 units, right? So 3 units here for the height. Let me just redo that multiplication sign. It's pretty shocking. So we'll try again. So 2 root 3 times by 3. That looks better. And this is all over 2. And if we just simplify this here then, 2 root 3 times by 3, that gives us 6 root 3. We obtain 6 root 3 over 2. And if we simplify this here then, we get 3 root 3. And there we have it. So that gives us the area of the equilateral triangle, giving us a solution to part B and the solution to this one practice question for this video. So that brings the end then of this video here on solving geometrical problems.